Today we will continue chapter 7 on the internet applications. Before we get started, just want to check how's homework doing. Have you guys started? Who has started? Is it going well, or did you? Okay. Okay, that's good. So don't forget, on Friday you'll be turning it in.
Friday?
Not Friday. On Monday. Okay.
That's good.
I live in the past. All right. So you can still work on it all over the weekend. Okay, I was like so nervous about it. Thanks. So just make sure, if you have any questions, try to visit the office hours. So just in case on weekends you don't reply as fast as possible. Okay. So yeah, you can bug me and the TA. Yeah.
Usually, I think about this, like Monday, do you have to submit by class or like late Monday, like 5 or 4?
Actually, it's supposed to be by class.
Okay.
Yeah, but sometimes people say the printer got some issue. Okay, so it's supposed to be by class. All right. Okay, so today we'll continue chapter 7. And in today's lecture, other than the regular materials that you will find on textbook, I will also show you how you can scrape data from the web. Okay, and we can demonstrate on Amazon. Okay, so we can try to see how we can collect data from web pages. Right? Okay, so to get started, let's review a tiny bit from last time. So last time, remember, we were talking about DTD, which is the document type definition. And if you can recall, we use a little bit of regular expression to denote these things. So basically, for example, for the first one, we're basically saying in this DTD definition, we're saying for our XML, we can have a book list that includes 0 or more book element. Okay? That's what the star sign means. And if we're using plus sign, it means 1 or more. If we're using question mark right here, it means optional, or to put it more precisely, we'll be talking about 0 or 1. So that's just regular expression. And here I put the regular expression list again, just so you don't forget. So normally, if we directly use comma, really similar to the criteria we have in NoSQL, we just imply it's an and. Okay, we are ending all of the terms. So it means expression 1 and expression 2 and expression 3. All of them have to be true. All right? So in regular expression, if you want to do or, you can directly use this. Quite intuitive. Right? Today we'll talk one more in terms of how we can write DTD. So of course in the exam I won't ask you to write DTD, but I might give you a DTD and give you an example saying does this follow the DTD? Right? So for this DTD, in DTD definition you can put different kind of, let's say, hashtags. For example, if we have hashtag PC data, it means we can only put the parsed characters. So instead of having this element including other elements, we can only put strings in there. Okay. For example, here the example would be for the author's last name. You don't want last name. Under last name, you have other kinds of hierarchy or nested information. So it will basically just be a string. So here we will say for content types, we can have element content or mixed content. Okay, so when we talk about element content, it's just basically like what you can think of in XML. You keep nesting the structure of the data. So for example, right here, we have book list, right? And inside book list, we have book. Inside book, we have author, okay? And author and title are on the same level of the hierarchy. So it's achieved by the indentation. So the most, I think most important concept in DTD when it can show the hierarchy is the fact that it can contain elements instead of just strings, okay? If it only can contain strings or integer, then the value will still be kind of like atomic, so that's what we learned in the relational model in SQL. But DTD can achieve hierarchy. So let's see. So here are a few more that we haven't learned before. For example, if you use hashtag required, it means this field is required. You have to provide it. And if you use this with a parenthesis and inside this or, it's kind of like enumerating the possibilities of choices that you can put. Okay. And if following the choices, you put a value, what do you think it will mean? If you, like, for example, for the book format, we say we can put either paperback or hardcover, and then right after the choices, we put paperback. Yeah.
Default value?
Yeah, if you don't provide any, then you have default value. Okay, so right here, I think this is a really simple concept to learn. So right here, for example, I'll write down an example and just tell me whether it's valid following this whole DTD rule. Okay. Let's say, so if you spot any mistake, then just tell me. Say today I have an XML which is supposed to be following the whole DTD rule. Can you spot any mistake out of it, or you think it's all correct? Yeah.
Last name, since it's not a question mark, is it a requirement?
Yeah, last name is required, okay? So right here we only have first name, so you're supposed to have last name, okay? What else? Genre is required, right? So here we have, I forgot to talk about this, but this, it means the attribute of the book element. So here we have genre that's required. So in order to fix it, you can say, okay, in the book, we have genre, and let's just say it's fiction. Okay, recall this is the way to put attribute in an element. Okay, what else? Or it's all correct? Yeah, I think then that's it. So we're not missing anything else. So what if today we only have book list, start tag of book list, and end tag of book list? Do you think that would be valid? Nothing inside, just start tag of book list and end tag of book list. Someone's nodding. So it will be valid, right? The reason being right there, for the element of book, we use star in the regular expression, so it means 0 or more. So you can have an empty book list according to this DTD. Okay? So simple as that. If this appears in the exam, something like this will appear here. Okay, that's the only way I'll test it. So I won't ask you to write down the whole DTD. Instead, you're given XML and match the DTD to see whether it's correct. Okay? And I won't test on too tricky regular expressions, just the simple ones. All right, so remember last time we talked about when we think about XML, we can think of very similarly. Right now we have JSON format, right? And one of the reasons, as I said, JSON format has largely replaced XML right now, and one of the reasons is because according to JSON format, it has a lot more benefit over XML in terms of either the compression rate when you compress the file, or for the parser to parse the format. Okay, parsing JSON is a lot more efficient, or what else? I think querying a lot of different information from JSON. Experimentally, it takes less time. Okay, so now we also have JSON, and JSON also carries the same characteristic as XML in the sense that it can help you to make the data hierarchical. Okay, so if that's the case, maybe JSON will have such thing close to as XML has DTD as well. Okay, even though whenever we talk about NoSQL, we kind of say it's schemaless or no schema. We don't care about schema. But maybe in real life, whenever we use JSON, it's still important for us to validate whether the JSON information you put in is correct based on according to different kind of application. So nowadays, JSON actually has their own way of validating the data, just like XML has DTD. JSON has JSON schema, but it's still a very not mature schema. It's still in draft right now. Okay, so we say JSON schema is the standard currently in draft, which provides coherent schema by which to validate a JSON item against. So it's the same thing as XML having DTD. Okay, you have something to check on as well. So I won't really go through details of it, but I will show you an example on our slide. I think it looks super tiny. It would just be something like this. Okay, and it looks small. It's because JSON needs more lines for the curly braces. Okay, but the idea is the same. So we started out having an object, and the object is the book list. In the book list, we can have properties, which is the book is one of the properties, and we keep nesting the information of it. Okay, so it's really similar, but because it's still in draft, a lot of the rules cannot be considered so far. So whenever you use JSON schema, maybe you would need some other script to help validating the form. For example, on your website, when you're entering a product. Okay, maybe you will need some other external script, external functions to help validating it. But so far, JSON can also do that. And I won't get too much into here, but I have references at the very end of the slide. You can go on to look at it as well. There are 2 blog posts that can give really detailed information of this. So because it's still in draft, I feel like I shouldn't really talk about this is the way it is. But if you want to use it in your project, you can see how it will work. Okay. So that's all we will talk about for the web data format so far. Okay, so we talked about HTML, which is the most simple one, only takes care of how things will look like, how things will be rendered on the web page, and then we move on to talk about XML, which takes care of bridging just HTML, just showing the format on the screen, and also the schema in relation to database. Okay? And then moving on from XML, we then talk about JSON, even though it's not mentioned in the textbook, but because nowadays that's what a lot of industry, a lot of companies are using, so we talk about JSON. And just to remember, JSON has actually a very similar idea as XML. Just the way they present things is different, and that helps a lot of benefit in terms of less data being stored or with higher compression rate, more efficient code. Okay. So that's all for web data format. Then the next thing I want to talk about today will be scraping data from the web. Okay. I think some of the teams have already scraped data from the web in order to populate their database. Which team has done that? Okay. You guys? Partially. So what tool did you guys use to collect the data?
We kind of have only done it for one team, so we just did it manually because it was very little data that we expensive. But we need to do it for bigger sets. Right?
Okay, cool. So for scraping data, you can think of it as writing a program that will automatically collect data for you, in the sense that you have a program, keep browsing whatever web pages you tell it to browse, and it will take the data down for you. But you can only get the ones you can see on the web page, so you can't get things from the backend. So whatever that's in the source code of the, whatever that's in maybe HTML code, XML code of the web page, then you can get it. Okay, but things other than that, you can't do it. I tried it before, it didn't work. For example, I was trying to say maybe I can connect to their database. Okay, it wasn't possible. So you can get whatever you can see. That's for web scraping. So web scraping in general, people like to scrape text, but also you can still scrape images if you want, because in the source code you can find the images link. So that's one way you can download it as well. So data scraping is often used when the API of the desired data set is not provided. For example, Twitter, a lot of researchers like to use Twitter, and Twitter actually provides really nice API, even though, as I said quite a few lectures before, they only provide you with 1% of the data. Okay, they are just hiding all the 99% back. They only give you 1%. But still, using their API is better than compared to if you want to scrape Twitter. Imagine if you want to write a program to get information from Twitter. It will be kind of bizarre, okay, because of the data amount. But today, say we have a website that's relatively manageable and you want to collect data from there, then scraping data is a good choice. Okay, so I think this will be useful in the sense that maybe you want to collect more product data for your project instead of keep entering them manually, continue this process. Maybe you can try to see how you can automate the whole thing. Okay, so I think there's a lot of different kind of tools for scraping, but I'm personally only familiar with everything that's related to Python. So I will show you in Python how it works. And it's very simple. It doesn't really require you to understand Python because the syntax is so simple. So some of the tools that people normally use, the most famous one is actually called Scrapy. But because when I first learned it, I was using Windows, and you guys know how things are like if you want to install some packages there. So I gave up. Then I moved on to the second package. It's called Beautiful Soup. Okay, the name I think is really cute, but I don't know why. I tried to look why they call it Beautiful Soup. Couldn't really figure it out. Yeah, that's their logo. I guess it's Alice in the Wonderland or something. They just don't have their own logo, and they have this big picture on their webpage. Okay, and other than that, they have no formatting or any design whatsoever. But it's such a powerful tool. I think in terms of the soup part, I still don't get it. You will keep constructing soup object when you're using Beautiful Soup. So it's like you just keep constructing soup. But the beautiful part is because they are being sarcastic about a lot of the code. When you really look into the source code of a lot of web pages, they call it ugly. So they help you to beautify it. Okay, so that's what the Beautiful Soup does. And there are also other software you can find online. But I don't really recommend them. So some of them will be, you enter a link onto a web page and it helps you to collect whatever you want. But I just feel like you have less flexibility out of that way because it determines what targets you want. I still think, in my personal opinion, writing code from scratch is better. Okay, so what we can demonstrate on is we can try on Amazon. So is there any particular thing you guys want to scrape? And last week was Halloween, right? And I was normally, for my recommendation, it would only show me these kind of books or bags or whatever, cosmetics. And last time it shows like Halloween stuff, and I saw like a can of like a rose something, and I was like, what is this? And I clicked in. It's a brand called Rose, but it's pork brain. And I was like, why would anyone want to eat that? But I was just so tempted to read through it, and I regret it so much. It just keeps haunting me in my head. People talking about how awesome it is. Okay, that's off the topic. What do you guys want to scrape? Oh yeah, and it keeps showing up because of the cookies. It remembers it. So then the next time I open it, I want to buy someone else, something else. Just because you viewed this and more pork product. Oh my god. So don't click things that you think you'll be afraid of. Anything? Any? Yeah.
Maybe some like Thanksgiving stuff.
Thanksgiving stuff.
Yeah.
Thanksgiving decoration. Okay. We have a turkey. Let's start from here. So, say our first goal is to get all of the product name. Okay. So I'm not sure how many of you have tried this before, but in most of the browser, I think now you can inspect element. So for example, if I just right-click on the turkey product name and you click inspect element, it will pop out like the source code of the whole web page, and mostly it looks really tiny here, but it will target on the part that you clicked. So right here, I'm not sure whether I can zoom in, but oh, I can. Okay, so right here it targets on the product name we clicked earlier. So if you can see, it's called the tissue turkey centerpiece party accessory right here. Okay, so that's the part we want, these texts. Okay, we don't really care about the class of the heading 2, but this is how we can get through there. So automatically, as you can think, Amazon, they won't have someone to write all of the product on the web page and then encode it. So they will automatically generate it in a sense that you can't just rely on the fact that all of the product name will be in heading 2 with this class. Okay, that's our assumption to start with. So what you can do, okay, let's say if you have Python, so I won't get into too much detail for the packages, but I'll show you how it works. Okay. So if you're using Python, and you will need to include two packages. The first one is URL lib2. It's just basically helping you to read the web page. That's all. Okay, nothing fancy. And the second one is Beautiful Soup. Okay, Beautiful Soup is from a BS4 package. All right, so let's start from reading. So the first thing you will want to do is to read this web page, okay, through the link. So what you can do here, we can say, I want to save the link in here, all right? Okay, here's another example. So as you can see, here we have like a really long URL and including the query we just searched, right? Remember last time we said HTTP itself, the protocol, it's stateless, so it doesn't remember anything you have done in the previous steps. And one of the ways to do it is cookie, and another way is using URL, right? Remember that we can extend URL in a way that remembers the steps. So, not sure about Amazon either, but maybe later on, if we, starting from here, we query other stuff, it will keep concatenating the query you have searched before. So it remembers your path somehow. Okay, so that's just one example right here. So here we store the URL, and we can say, let me see, what should we do? So we can read it. Some pleasant music there. So we can open the URL, okay? So then now the response object was stored. So it already visited the web page, okay? And get the information. If you guys want, I can post the script, so, okay? All right, then, right now we have the response object, but it hasn't given us the HTML code, so we can store it as string. Okay, by doing this, HTML equal to response dot read. Okay, so it just basically reads all of the HTML code as string in response, and then we store it in the HTML variable. If you're not familiar with Python, you can see so far we didn't try to declare anything. Okay, so for using variables in Python, you just directly use it and you don't even tell the data type. It's really fast, okay? They would just automatically assign data types to the variable. Okay, so now we have HTML. Let's take a snippet of the HTML to see whether it works. So we can try to see the first maybe 100 characters, and you can see, okay, it started out, that looks somehow like HTML code already. So what we want to do next is the core of Beautiful Soup. So it's we want to make a soup object. So what we mean by the soup object is that, I'll just call it soup, and you can make a beautiful soup out of it. So all the beautiful soup, the ingredients are the HTML. Okay. So now the soup itself, it has already helped you to organize the HTML code in the sense that you can trace the soup just based on maybe the class and the tags that we saw in the code. So let's go back to the source code. So right here, this is the one we want. Is it? Where is it? Let me try again. We want this turkey name. All right. So this is the one we want. Okay. So I'll show you how you can do to collect all of the information. So the way to do it, now we have the soup object, right? So the way to do it is we want to find stuff from the soup. Let's say we use .find, and because earlier we saw it's a heading 2, so you say I want to find the H2, okay? Where the H2 has such attributes of, for example, we saw the attribute class has the value like this, right? That's what we directly copy from. Okay, the class will be described in this way. So you don't really have to worry why they describe it this way. It looks really messy, but it's just when they are designing it, Have you guys heard CSS before? CSS, the style sheet, right? So this is just how they tell for the style sheet how it will be rendered, okay? Different kind of formats. So I just say for in the soup, I want to find the heading 2. If you remember, H1 is like heading 1, H2 is heading 2. So I want to find the heading 2, which has the attribute of class equal to this value. That's it. Okay, and you can see here we will use just key value pairs to list the attributes. And if you have more criteria as you want, you can just keep continuing with comma and then more key value pairs. All right, so if you hit enter, oh my God. Oh, right. So if you hit enter, you can see now it finds the first one, which is H2 with the class and with that turkey information, the product name in there, okay? So if you say, I don't like the fact that it gives me so much information, like outside right here, I only want the name of the product, then we can do get text, then it gives it just the name right here. Starting from here, that's just the name of the product. Impressive, right? And it starts with a U, that's because of the Unicode problem. You guys don't have to worry about it, okay? It just all starts with a U. So here you can see we only have just one product name. What if we want all of them? So really simply, you can just do, let me see. What you can do is, for example, you can say I will store all of the product names by doing find all. Okay. So if you only do find, it will only give you the first one, but if you do find all, it will give you all of the names that satisfy it. Okay. So now we can see, for example, the product names. The first one is the turkey. Now I still keep the text. And the second one is Happy Thanksgiving Streamer Party Accessory. And then third one. Okay, even longer name. It's just leaves. All right. So then, for example, we can see how many products we have collected, and out of that page we have 15 of them. Okay. So now you see how you can collect, for example, the name. And then the price, you can just follow the same steps by identifying what are the tags, what are the class for the price. Then match two of these arrays together, and you get the names of it. So how about iterating through different pages, because now we only get the first page. So the way to do it is to make the approach more generalized. Whenever you find these things, you can try to see whether on the link you will see any page information. If it doesn't, you can click on the second page. If you click on second page, sometimes then it will show, like here, you can see reference SRPG2. It means it's the second page. So let's just assume it works, and it will change to third page, and it will show you more information. Okay? So that's a super rough introduction for how you can do scraping. Okay? I don't want to put too much detail in it because I don't think everyone will need it, but I think it will definitely come in handy. Doesn't matter for the project or in the future. Okay, so when I go back, I will paste the exact same code for you guys on Angel, and you can try to play around with it. All right? Okay, so rough discussion on Beautiful Soup. Then let's take a look at the later materials in this chapter, which is less exciting, but important in some sense. All right. So now we want to talk about a little bit of how the internet application have evolved in some sense. Okay, so started out, I think internet hasn't been around that long, but in the past the application was very different. Who's familiar with P2P? Some people, yeah, like I think like file transfer, right? You can sometimes not properly, but you can download some stuff, and that's through another peer in the P2P software. Okay, these kind of things. But now it's kind of gone, but it was a big thing before. And even earlier, maybe when internet first started, there was no such thing, and the application was a lot more simple, okay, back then. So right now we want to talk about these internet application of internet systems that we call it data intensive, okay? So everything's based on data. Then generally for these data intensive internet systems, they can be divided into 3 components, which are the data management, application logic, and presentation, which we will talk about separately later. So the system architecture determines whether these 3 components reside on a single system, which we call like just one tier, or are distributed across several tiers. Okay. So as you can imagine from the very beginning of these data-intensive systems, it all started out as single machine, but nowadays it will be more distributed. So the first version, we started out by single tier, and then we will move on to 2 tiers and then 3 tiers. Okay. For single and 2 tiers, we can think of them as the predecessor of 3 tiers. So this first one, single tier, the architecture looks like that on the right-hand side. So as you can imagine, what will this thing be? Yeah, that's the database. Okay, so that's the DBMS right there. Okay, so sitting on top of the database, we will have the application logic of it. Okay. So basically, you might have some functions wrapping to help you access the database or provide you back with different kinds of results. And sitting on top of the application logic, we will have the client. Okay. The thing that wrapping all of them together, including the client, the application logic, and the big database, is a mainframe. Okay, so the mainframe wraps it all. So as you can see, this thing we can call it just one tier. It's just a single tier. So all of the functionality are combined into a single tier, usually on a mainframe. Okay, so that's the outer part. And user access through the whole system, through the DOM terminals. So you can think of DOM terminals as just super boring interface, okay, the black background one, and you can only do some really simple input and display. Okay, so that's back in the time when the whole data-intensive system first started. So they weren't really providing any graphical interface, it's just the DOM terminals. Not the one the cashiers use, though. I think those are not that DOM yet. Okay, so this, back then, DOM terminals are the really simple ones. So the advantage of this is easy maintenance and administration, because you're not distributing anything out. Okay, everything is so self-contained. It's just within this single machine. But the disadvantages of it is just later on people are expecting more of a graphical interface, and also, if today you need to work on different kind of machines, they need to be worked together, then the centralized computation of all of them is too much for a central system. So it's also hard for them to communicate because you have everything just wrapping together. So then we move on to 2 tier. So this is single tier from the very beginning. So for 2 tier, we started out like this. Okay. So as you can see, we already have database management system separate from the client side. Okay. So the DBMS is still with application logic, and through the network, we can connect to the client side, multiple clients. And for this kind, as you can see, for the client side, we don't have anything else. It's just the client itself. So for this kind of 2-tier architecture, okay, for 2-tier, we also call it client-server architecture. For this kind of 2-tier architecture, we also call it thin client, because the client doesn't carry anything else. So the client, the only thing they do is implement the graphical user interface. Okay, just the interface, nothing else. All of the logic sits on top of this, right? So we call it a thin client. And for this kind of architecture, server implements the business logic and data management. Okay, so business logic is just basically the application logic. And as you can see, we can think of here the website as the server computer, and the right side as the client and computer, and they interact with each other through the network, or you can think of it as like a protocol for them to communicate. Okay? So this is the first version of the two-tier. Then we have a second version of the two-tier. So some people might think, I want the client side to be more powerful, so instead of having the application logic only sitting on top of here, I just give every single client the application logic. So everyone carries one. So as you can imagine, the previous one is called the thin client. So what do you think this one will be called? The thick client, yeah. I think it's kind of lame, but that's just how it's named. So here we say, the client implements both the graphical user interface and the business logic, okay? And the server now only takes care of database management system. So some of the disadvantages of this will be like no central place to update the business logic because now everyone has a copy of it. So when you want to update it, it's a lot harder, right? And then secondly, you can say security issue. Server needs to trust the client. One example will be, for example, the server side is the bank, and all of the client side is ATM. Okay, so the server needs to trust in the sense that the bank has to trust all of the ATM machines will operate in the same way, operate correctly. Otherwise, maybe some machines, when whatever you input, it gives you like 100 times back, then the bank will be in trouble. Okay. So there are some pros and cons of it, and also because the client is so heavy. A lot of time it's harder to scale because you have to rely on the fact that everyone will get a copy of the application logic. So that's for second tier. Okay, so now second tier also compared to the single tier, it has more than just DOM terminals because we have the graphical interface. Another thing to talk about for the security issue in the sense that the server has to trust the client. Okay, so here we say it will be a problem because the application logic are sit separately on each client, right? So can you think of maybe there will be one solution that would make this not so big deal? Maybe in what way the database can take care of more functions. So everyone just directly use the function the database provide. Then there will be less problem. What I'm trying to say is, for the database, they can use store procedure, like the thing we learned before. If they use store procedures, then there will be less variety of how things will be implemented. Okay, so that's one benefit of having store procedure in this sense. Okay, then moving on, people think second tier, two-tier is still not enough, not ideal enough. So then we move on to have a three-tier architecture. Okay. So compared to the two-tier architecture, the three-tier separates a bit further, and now we have three tiers, right? So the first tier is the presentation tier. You can think of your project more in this way. Okay? It's the presentation tier, which takes care of the interface to the user. And also nowadays, compared to the past, nowadays they will also focus on adapting to different devices. Okay? So some of you, for the project, you might be later on allow the fact that when I use my phone, I can also see your project, and then it will be rendered differently. Okay, the framework will look differently. So maybe on the laptop it looks one way, on tablet it looks one way, and on the phone it looks another way. Maybe you want to do it on the watch, that's another way. Okay, so it has different kind of interfaces, but same thing, representing the same thing. And for the second tier, we call it the middle tier. And now for the middle tier, it implements the business logic and also implements the complex actions, maintains the states, which I'll talk about later. Okay, and also the middle tier can access different data management systems, right? Then finally, the last tier will be the data management tier. As you can see, this is where the database sits. Okay, so everything we have learned before in terms of how the relational data model was designed and how the SQL was done, everything of that is in database management tier. So for the next slide, I'll just quickly show you some of the technologies that are being used in terms of these three tiers, but some of them are pretty outdated, but just give you the sense of which technology relates to which. Okay. So just remember we have presentation tier, middle tier, and data management tier. So in this slide, again, presentation, middle, data management. So for the presentation part, we can either use JavaScript or we can have cookies, okay? So you can think of them mapping to the web browser. And for the middle tier, we have application logic. So here, some of the tools we will use, maybe JSP, okay, servlets, or XSLT. And if you recall from last time, okay, the way that you can communicate these two tiers is actually through HTTP. Okay, so that's the communication protocol that we will be using. So through HTTP, we can communicate with application logic in the browser. And if you recall last time, we said the browser is the client. Okay. And in terms of communicating between the middle tier and the database management system, so you can imagine, will be the JDBC and SQLJ we have learned before. Okay. And if you remember, so here maybe we can have things written in Java, then we will want to use JDBC. Question? Which part do you know? Oh, okay. Here. All right, so previously we have introduced the single tier and two tier, and now I'll show you how the three tier will look like. Okay, so three tier basically just separates them all, and between them we all have their own protocol of communicating. Okay, so as you can see, this will be the data management tier, right? And this will be the middle tier, takes care of the application logic, and this will be the presentation tier. Okay. And inside the network, we might have HTTP as the communication protocol. We can use JDBC, different stuff. Okay. Then later on, we will talk about each tier separately. But we won't talk about the database management tier because that's what you're already doing. Okay, that's the DBMS part. So for the presentation tier, it provides forms through which users can issue requests and display responses that the middle tier generates. So one example, for example, you can use HTML to render things. Okay, that's one approach. And code should be easy to adapt to different display devices and formats. So as I said before, maybe on laptop it's one way, tablet is one way, and then on your phone or your watch, it's all different way. Okay, so all these things, one of the most popular way of taking care of rendering differently on different devices is through using style sheet, CSS. So who has developed web pages that will look differently on different devices before? You have? So did you do it with CSS?
Yeah.
Yes, so in CSS you can, I think one of the ways is maybe when the resolution is between a range, then you assign different kind of designs, right? So these things can be done in CSS. We will go through a quick view of CSS next time to show you what they mean, but I think most of you heard of it before, right? Takes care of the design of the web page. Okay. So in some sense, before we move on to the middle tier, you can think of middle tier later as the tier that takes care of what to display, okay, the what, and the presentation tier of how to display things. So for CSS, it doesn't really care about what the contents are, what text you want to render, but it cares about how things will look like, okay? So middle tier is what data, and then presentation tier is how it looks like. So for the middle tier, it controls what data needs to be input, and then controls the flow between multi-action steps in a sense that here the multi-action means, for example, we go to Amazon and we first put things into the shopping cart and then remembers it, and then you decide, or you keep browsing and it's still there, and then later on you go to checkout, okay, and then you check out, it has to remember what you have stored in the shopping cart before, and after you check out, you pay, and then it has to remember the fact that you have paid, and after you paid, it has to clear out the shopping cart. All these steps. So these are what the middle tier is taking care of. So as you can imagine, the presentation tier does not care. Right? It doesn't care about what you have put in the shopping cart. It just takes care of rendering it. Right? Other than that, middle tier also takes care of controlling access to the database layer. So as you can see, between middle tier and database tier earlier, we have JDBC. So that's how we can access the database. And sometimes, middle tier will help you to assemble dynamically generated HTML pages from database query results. So sometimes, instead of, So this part, for example, you return different stuff from the database, and then you want to render different things. So middle tier is the part that helps you to generate the HTML code, and then go up and send to the presentation layer, saying these are the things I want to display. And maybe based on this HTML code, the presentation layer will then tweak it based on the CSS, and then render it differently. Okay. So just a few more things to go through to give you a better sense of how these can map to some real-life example. For example, for airline reservation. Okay, for the database system tier, all we care about, all it takes care of is the airline information and the available seats or customer information. And in terms of the application server, it takes care of the logic to make a reservation, to cancel reservation, or today there's a new airline open. Okay, application server takes care of it. And for the client program, it displays the forms and human-readable output and field validity checking. Okay, so you can see that's how they separate the task. The application server will not try to display any kind of forms for the client program, which is the presentation tier, or the database system will not try to implement functions unless you store procedure. So that's the difference. Another example would be, for example, we have course enrollment. Okay? Then when enrolling the courses for the database system, which is the database management tier, we might have the student information, course information, instruction information, things like that. In the application part, it will take care of the logic to add a course, drop a course, create a course. Okay? And the presentation tier, it display the forms and human readable output. Okay? And also field validity checking. So after here, I actually have slides for just talking about the advantages of the three-tier architecture. And I think I won't really talk about it because it's, just read through it and then you get it. Okay? So that's, actually that's it for today. And on Friday, I will finish chapter 7, which only have a few bits left. So Friday might be a short lecture, not sure. And just remind you again about what's going to happen for next week. Monday, okay, here I see, Monday homework 4 due, so it's not Friday, okay? Monday homework 4 due, and we will have review session for the midterm 2, and Tuesday, midterm 2, part 1. Supposedly it's going to be programming, okay? SQL, yeah. I'm not sure whether our test on NoSQL is very technically hard, so maybe you guys can relax about it. So SQL for sure. Okay, I won't like test you on NoSQL and not testing on SQL. Okay, because you guys have done it on the homework, so I think I'll just test on SQL. And Wednesday no class, next Wednesday, and next Friday, midterm 2, part 2. Okay, the writing part. What?